Dezember 14. 1940, Wehrmacht Vehicle Depot, Böblingen, 18 kilometers south of Stuttgart, Germany. The morning fog hung thick over the Böblingen Vehicle Depot, a sprawling facility of corrugated metal workshops and muddy repair yards, located just beyond the industrial outskirts of Stuttgart. Oberfeldwebel Karl Zimmermann stood outside Workshop 7, his breath forming clouds in the bitter December air, as he watched a military transport truck rumble through the main gate. The temperature hovered just above freezing, and patches of dirty snow clung stubbornly to the shadows between buildings. Inside the depot's various workshops, the familiar symphony of repair work echoed across the complex. Pneumatic wrenches hissing, metal hammers striking against stubborn bolts, and the occasional grinding of machinery being coaxed back to operational status. Zimmermann, a veteran mechanic with 16 years of experience maintaining everything from motorcycles to half-tracks, had seen countless vehicles pass through these workshops since the facility's expansion in 1941. At 42 years old, with grease perpetually embedded beneath his fingernails and a reputation for solving impossible mechanical problems, he had become the depot's unofficial chief troubleshooter. The transport truck backed carefully toward Workshop 7's loading bay, its engine sputtering in the cold morning air. Behind Zimmermann, 3 younger mechanics emerged from the workshop's interior, drawn by curiosity about their new assignment. Gefreiter Hans Weber, barely 23 and fresh from technical training in Munich, adjusted his wool cap against the chill. Beside him stood Unteroffizier Friedrich Kohler, a precise and methodical 30-year-old who had worked in his family's machine shop before conscription, and Gefreiter Otto Braun, a farm boy from Bavaria whose natural mechanical intuition often surprised his more formally educated colleagues. The truck's tailgate dropped with a metallic clang, revealing their unusual cargo, a small boxy, olive-drab vehicle that looked almost toy-like compared to the massive German military trucks and armored vehicles that typically occupied the depot's repair bays. The American Willys MB Jeep sat in the center of Workshop 7's main bay, looking peculiar and out of place among the familiar silhouettes of German military vehicles. Morning light streamed through the workshop's high windows, illuminating particles of dust and metal filings that danced in the air above the concrete floor. The space itself was a cathedral of mechanical repair. Workbenches lined the walls, each cluttered with tools, gauges, and partially disassembled components. Overhead, a system of chain hoists and pulleys hung from exposed steel beams, ready to lift engines and heavy assemblies. The walls displayed shadow boards where wrenches, hammers, and specialized tools hung in organized arrangements, though gaps in these displays testified to the increasing difficulty of obtaining replacement equipment. A large cast-iron stove in the corner provided inadequate warmth, its chimney pipe snaking upward toward the roof. The Jeep itself appeared to have endured considerable hardship before its capture. Its olive paint was scratched and faded, revealing bare metal in several locations. The canvas top had been removed or lost, and mud caked the undercarriage and wheel wells in thick, dried layers. One headlight assembly hung loosely from its mounting bracket, and the windshield showed a spiderweb crack in the lower left corner. Despite this rough appearance, the vehicle possessed an undeniable presence, compact, purposeful, and fundamentally different from anything in the Wehrmacht inventory. Zimmermann circled the Jeep slowly, his experienced eyes cataloging damage and making mental notes. The accompanying paperwork indicated the vehicle had been captured 3 weeks earlier during fighting near Monte Cassino in Italy, transported north through Austria, and designated for technical evaluation. The assignment seemed straightforward: restore the Jeep to operational condition, document its mechanical systems, and prepare a detailed technical report for the Ordnance Evaluation Committee. What Zimmermann could not yet know was that this routine assignment would fundamentally challenge everything he understood about military vehicle design and industrial production philosophy. Zimmermann's team gathered around the Jeep as cold. December sunlight painted rectangular patterns across the workshop floor through the high windows. The temperature inside Workshop 7 remained barely more comfortable than the frigid exterior, despite the stove glowing red in the corner. Hans Weber produced a leather-bound notebook and began sketching the vehicle's exterior dimensions, while Friedrich Kohler carefully photographed each angle using the depot's precious Leica camera. rationed film requiring him to consider each shot carefully. Otto Braun had already crawled beneath the vehicle, his muffled voice describing what he observed to Weber, who transcribed the details in neat handwriting. The jeep measured approximately 3.5 meters in length and just over 1.5 meters in width, remarkably compact compared to the Wehrmacht's Kübelwagen or the various requisitioned civilian vehicles pressed into military service. Its ground clearance appeared generous, and even a cursory examination revealed a robust suspension system designed for punishment across rough terrain. The 4 wheels, each mounted with distinctive crosshatch tread tires, seemed almost comically large in proportion to the vehicle's diminutive body. Zimmermann ran his hand along the hood's pressed steel surface, noting how thin the material felt compared to German military vehicles, yet the construction appeared solid despite this economy of material. The dashboard, visible through the cracked windshield, displayed a Spartan simplicity. A few gauges, minimal switches, nothing extraneous. Unlike German military vehicles with their sometimes complex control layouts, this American machine seemed designed for operation by someone with minimal technical training. The steering wheel, a simple thin ring of metal, offered no padding or comfort considerations. The seats consisted of canvas stretched over metal frames, functional but hardly luxurious. Every element spoke of ruthless efficiency, of weight reduction, of manufacturing simplicity. Weber completed his exterior sketches and moved to examine the engine compartment, his fingers finding the hood latches. The hood itself, when raised, revealed an access design that startled the team. Unlike German vehicles where engine access often required removing multiple panels or extensive disassembly, this American design offered nearly unobstructed visibility and reach to every major component. The second morning brought clearing skies and even colder temperatures. Frost patterns decorated the workshop windows, and the team's breath formed visible clouds despite the stove burning steadily since dawn. Zimmermann arrived early, as was his habit, spending 30 minutes alone with the jeep before his team assembled. He had worked on vehicles for nearly 2 decades, from civilian automobiles to heavy military equipment, and had developed an instinct for mechanical systems, a kind of intuitive understanding of how engineers thought, how they solved problems, how they made compromises between performance, cost, and manufacturability. This American vehicle intrigued him in ways he found difficult to articulate. When his team arrived, they began the systematic disassembly process. Kohler had prepared a detailed documentation system, assigning each component a reference number and photographic record before removal. This methodical approach reflected German engineering culture, thorough, precise, documented. They started with the obvious damaged components, the loose headlight assembly, which required only tightening of mounting bolts, and the cracked windshield, which they carefully removed as a complete unit. The windshield's folding hinge mechanism impressed them immediately, simple, robust, requiring no tools for operation, allowing the glass to fold flat against the hood to reduce the vehicle's profile. Braun pointed out the elegant simplicity of the design, noting how it accomplished multiple purposes with minimal parts. As they continued working, removing smaller components and accessories, a pattern began emerging. Every fastener used standard sizes. Every bolt head accommodated the same limited set of wrench sizes. Unlike German military vehicles, which sometimes required a dozen different tools for maintenance, this American machine seemed designed for service with perhaps 4 or 5 basic implements. Weber discovered that many components attached with simple cotter pins rather than threaded fasteners, faster to install during assembly, easier to remove during field maintenance. The Jeep was revealing itself not as a precisely engineered masterpiece of individual craftsmanship, but as something entirely different, a machine designed not for perfection, but for mass production and field serviceability by minimally trained personnel. This philosophical difference would become increasingly apparent as they delved deeper into the vehicle's mechanical systems. Heavy gray clouds rolled across the Stuttgart sky as Zimmermann's team prepared to remove the Jeep's engine, the heart of any vehicle and typically the most complex system requiring analysis. Outside, a light snow had begun falling during the morning, covering the depot grounds in a fresh white blanket that temporarily concealed the mud and industrial grime. Inside Workshop 7, the team positioned the overhead chain hoist above the engine compartment, its heavy hooks and chains clinking softly as Kohler maneuvered the apparatus into position. The workshop's ambient temperature remained stubbornly cold, despite their best efforts, and the mechanics worked with fingerless wool gloves to maintain dexterity while preserving some warmth. Zimmermann directed the operation with hand signals, while Braun and Weber worked beneath the vehicle, disconnecting the transmission linkage, exhaust system, and driveshaft connections. The process itself felt strangely efficient. Unlike German vehicles, where engine removal often required hours of preparation, navigating complex component arrangements and carefully documenting wire harness positions, this American design seemed almost eager to surrender its power plant. The engine mounts used simple rubber isolation bushings and 4 substantial bolts accessible from above. No hidden fasteners, no components requiring specialized tools, no unnecessarily complex routing of cables or hoses. Within 90 minutes, a remarkably short time that surprised even the experienced Zimmermann, they had the engine suspended from the hoist, slowly raising it clear of the chassis. The power plant swung gently on its chains, still dripping oil and coolant from disconnected lines. Weber positioned a heavy wooden workbench beneath the hoist, and they carefully lowered the engine onto its surface, where it sat like a mechanical sculpture awaiting examination. The engine itself appeared almost crude at first glance, a 4-cylinder inline configuration, nothing sophisticated or revolutionary about its basic architecture. Cast iron block, side valve design, simple and old-fashioned compared to the overhead valve engines found in some German vehicles. Yet as Zimmermann began his detailed examination, running his experienced hands over the casting surfaces, checking the machining quality, and noting the construction details, he found himself increasingly fascinated by what this engine represented. The afternoon light, filtered through snow-laden clouds, cast a grey pallor across Workshop 7 as the team gathered around the disassembled engine components. They had spent the past 3 hours carefully removing the cylinder head, examining the valve train, and beginning to measure critical dimensions with precision instruments borrowed from the depot's quality control department. Kohler, with his background in precision machining, took responsibility for the detailed measurements, his calipers and micrometers clicking softly as he recorded dimensions in a growing ledger of specifications. The engine's displacement measured approximately 2.2 liters, producing an estimated 60 horsepower, modest by German standards, where engineers often pursued maximum power output, even at the cost of complexity and manufacturing difficulty. What struck Zimmermann immediately was not the engine's performance characteristics, but its manufacturing philosophy. Every component showed evidence of mass production techniques optimized for speed and simplicity. The cylinder block's casting quality was good, but not exceptional. Germany produced superior castings with tighter tolerances and more refined surface finishes. Yet this American block had clearly been cast in enormous quantities, probably thousands per month with minimal hand finishing required. The machining operations showed tool marks indicating rapid, aggressive cutting, rather than the careful, precise approaches German machine shops employed. Weber discovered something remarkable while examining the connecting rods. Each rod bore a simple stamped number, and when he measured multiple rods against each other, he found them virtually identical, within a few hundredths of a millimeter. This level of consistency in mass-produced components suggested manufacturing processes and quality control systems operating at scales difficult to imagine. German factories produced excellent components, but often required skilled craftsmen to hand-fit and adjust parts during assembly. These American parts seemed designed to simply bolt together, no adjustment necessary, no skilled fitting required. Braun pointed out the simplicity of the lubrication system, a straightforward pressure-fed design using a gear-driven oil pump, with generous clearances that could tolerate both dirt contamination and maintenance neglect, far better than more precisely engineered German systems. Every design choice reflected a fundamental philosophy. This engine was built to be manufactured by the tens of thousands, maintained by minimally trained soldiers, and operated under conditions that would destroy more sophisticated designs. December 17, 1943, Workshop 7. Just in 1 2 hours, Morning arrived with clearer skies but even more bitter cold, the thermometer outside Workshop 7 registering -8 degrees Celsius. Inside, the team had arrived early, driven by growing curiosity about their unusual project. The cast-iron stove glowed intensely, consuming precious coal at an accelerated rate as they attempted to maintain working temperatures. Zimmermann stood before a large workbench where they had arranged dozens of components removed from the Jeep: fasteners, brackets, hoses, electrical connectors, and various mechanical parts laid out in organized rows, like artifacts in a museum display. Weber had spent the previous evening cataloging every bolt, nut and washer removed during disassembly, and his findings had prompted this morning's special examination. He presented his analysis to the team, his notebook open to pages filled with neat diagrams and measurements. Of the approximately 200 individual fasteners used throughout the Jeep's construction, only 7 different sizes appeared. 7. Zimmermann felt this number sink in as he processed its implications. A comparable German military vehicle might use 15 or 20 different fastener sizes, sometimes requiring specialized tools for specific applications. But this American machine had been designed around radical standardization. Weber demonstrated his discovery using the actual parts. The same half-inch bolts that secured the engine mounts also attached the seat frames, secured the body panels, and fastened numerous other components throughout the vehicle. The same thread pitch, the same head size, interchangeable throughout. A mechanic in the field could carry perhaps 3 wrench sizes and handle virtually any repair or adjustment the vehicle might require. Kohler expanded this observation to other systems. The electrical system used standardized connectors throughout, the same connector type for headlights, instruments, and switches. Unlike German vehicles with their variety of proprietary connector designs, often specific to individual manufacturers or even specific vehicle models, this American approach meant any connector could potentially be sourced from any other vehicle of the same type. The implications extended far beyond simple convenience. Standardization at this level meant training became easier. A mechanic learned one system applicable throughout. It meant supply chains simplified, fewer unique parts to manufacture, stock, and distribute. It meant field repairs accelerated. Soldiers could cannibalize parts from damaged vehicles to keep others running. December 17, 1943, Workshop 7, 15:30 hours. The afternoon brought a discovery that would fundamentally reshape the team's understanding of American industrial philosophy. Brown, while examining the transmission assembly, noticed something that initially seemed like a quality control failure. He called Zimmermann over, pointing to a gear set showing slight asymmetry in its machining marks. In German practice, such variation might indicate sloppy manufacturing or poor quality control. However, as Zimmermann examined the transmission more carefully, a different picture emerged. The transmission had been assembled from components bearing date codes, showing they were manufactured weeks apart, possibly in different facilities. Yet despite this distributed production, everything fit together perfectly. The gear meshes showed proper spacing and alignment. The bearing tolerances were correct. The synchronizer mechanisms operated smoothly. This wasn't poor quality control. This was something far more sophisticated. Truly interchangeable parts manufactured at scale across multiple production facilities. Kohler retrieved a technical manual they had found in the Jeep's storage compartment, its pages stained and worn from field use. The manual's parts diagrams showed exploded views of every major assembly, with part numbers clearly marked. More significantly, the manual included tolerance specifications and assembly procedures, written in clear, simple language, intended for soldiers with minimal technical training. German technical manuals, by comparison, often assumed significant mechanical expertise and contained complex technical terminology. This American approach to documentation reflected the same philosophy evident in the hardware. Designed for the lowest common denominator of skill, enable rapid training, assume minimal prior knowledge. As afternoon faded toward evening, and the workshop's light became increasingly dependent on overhead electric fixtures, the team gathered around the partially disassembled Jeep. They had removed dozens of components over the past 4 days, examining, measuring, and documenting everything. A pattern had emerged with such clarity that it could no longer be ignored. This vehicle represented a fundamentally different approach to military Equipment design, one that prioritized manufacturing efficiency and field serviceability over technical sophistication or performance optimization. It was in many ways the opposite of German engineering philosophy, which emphasized precision, craftsmanship, and technical excellence, even when such priorities complicated production or maintenance. December 20th, 1943, Workshop 7. 8 to 45 hours after a weekend break, the team returned to Workshop 7 on Monday morning to find Zimmermann had arranged a special comparison. Parked alongside the partially disassembled American Jeep sat a Volkswagen Kübelwagen, the Wehrmacht standard light military vehicle designed by Ferdinand Porsche and produced at the Wolfsburg factory. The Kübelwagen represented German engineering at its finest. Air-cooled engine for reliability in diverse climates, sophisticated suspension system based on torsion bar technology, excellent cross-country mobility, and meticulous attention to engineering detail. The contrast between the two vehicles, sitting side by side in the cold morning light, could hardly have been more stark. The Kübelwagen's body displayed the characteristic German attention to detail. Beautifully formed sheet metal panels, carefully finished edges, precisely fitted components that spoke to craftsmanship and quality. Its engine, though also modest in power output, incorporated more sophisticated design elements. An air-cooled flat-4 configuration that eliminated the need for coolant and radiator systems, reducing weight and mechanical complexity while providing excellent reliability. The vehicle's interior featured more refined appointments, better weather sealing, and more comfortable seating compared to the Spartan American Jeep. By almost any measure of individual vehicle quality, the Kübelwagen was superior. Yet as the team began a systematic comparison, uncomfortable questions emerged. Weber examined the Kübelwagen's undercarriage and counted fastener sizes, 19 different types requiring a much larger assortment of tools for maintenance. Braun investigated the body panel attachment methods and found each panel required specific mounting hardware, making replacement in the field significantly more complex than the Jeep's simpler approach. Kohler studied the electrical system and discovered a variety of proprietary connectors and switches, many unique to Volkswagen's design, meaning replacement parts had to come from Volkswagen production or specialized suppliers. The Kübelwagen's sophisticated torsion bar suspension, while providing excellent ride quality, required specialized knowledge for adjustment and repair, not something an average soldier could manage with basic tools in a field workshop. The air-cooled engine, despite its reliability advantages, required more complex manufacturing processes and more precise machining tolerances than the Jeep's simple water-cooled design. December 20th, 1943. Workshop 7, 14 Naus hours. The afternoon session brought increasingly uncomfortable realizations as the team's analysis deepened. Zimmermann retrieved production data from the depot's administrative office, comparing manufacturing numbers for German military vehicles against estimated American production figures based on intelligence reports. The numbers told a sobering story. Germany's entire automotive industry, including Volkswagen, Opel, Daimler-Benz, and numerous smaller manufacturers, produced approximately 40,000 light military vehicles in 1943. Intelligence. Estimates suggested American factories manufactured more than 300,000 Jeeps in the same period, nearly 8 times German production of comparable vehicles. But the disparity extended beyond simple numbers. The Kübelwagen's production required skilled craftsmen, specialized tooling, and complex supply chains delivering hundreds of unique components from various suppliers. Assembly time per vehicle exceeded 40 hours, with significant hand-fitting and adjustment required during construction. By contrast, the Jeep's design philosophy enabled production by less skilled workers using more automated processes. Its radical standardization and simplified assembly procedures reportedly reduced production time to under 15 hours per vehicle. The team spread technical drawings across a workbench, comparing engineering approaches. German designs showed meticulous attention to optimization, every component carefully engineered to perform its function with maximum efficiency, minimal weight, and elegant integration with surrounding systems. The drawings were beautiful in their precision, Representing countless hours of engineering refinement, American designs, by comparison, appeared almost crude. Less optimization, more generous tolerances, simpler solutions that sometimes seemed inelegant. But these apparent simplicities enabled something German designs could not. They could be manufactured rapidly, by relatively unskilled workers, in enormous quantities, with minimal specialized tooling. Kohler voiced what everyone was thinking. They've sacrificed elegance for quantity, individual quality for mass production capability. It was true, but the implication was devastating. In a war of attrition, where replacement rates and numerical superiority increasingly determined outcomes, which philosophy would prevail? A smaller number of superior vehicles or a vastly larger fleet of adequate ones? The answer seemed increasingly obvious and increasingly uncomfortable. Light snow fell steadily outside Workshop 7 as the team gathered for what had become less a technical evaluation and more a philosophical discussion about manufacturing, engineering and industrial war-making capability. Zimmermann had invited Hauptmann Ernst Wagner, the depot's technical officer and a former automotive engineer from the Daimler-Benz works in Stuttgart. Wagner arrived mid-morning, stamping snow from his boots and rubbing his hands together against the cold. At 56 years old, Wagner represented the pinnacle of German engineering education. Trained at the Technical University of Berlin, 30 years of experience in automotive design, holder of several patents related to transmission systems. He approached the Jeep with evident skepticism, circling it slowly while the team stood back respectfully. Wagner's initial comments reflected traditional German engineering values. He noted the thin body panels, criticized the simple suspension design as crude, and pointed out numerous areas where German engineering would demand more sophisticated solutions. But as Zimmermann guided him through their detailed analysis, showing the documentation they had compiled over the past week, Wagner's demeanor gradually shifted. He examined the standardized fasteners, studied the interchangeable parts, and reviewed their production estimates. His questions became more thoughtful, less dismissive. He spent considerable time examining the engine components, measuring tolerances, and comparing them against typical German manufacturing practices. Finally, Wagner straightened, removing his reading glasses and polishing them with a handkerchief, a gesture the team recognized as indicating deep thought. His assessment, when it came, was measured but profound. The Americans, Wagner explained, had solved a different problem than German engineers typically addressed. German engineering culture emphasized optimization, creating the best possible solution for a specific application, maximizing performance, minimizing weight, achieving elegant integration of systems. This approach produced superior individual products, but imposed significant costs, complex manufacturing requirements, extensive skilled labor, difficult supply chain management, and limited production capacity. The Americans had apparently decided that in modern industrial warfare, these traditional engineering virtues were less important than manufacturing velocity and logistical simplicity. They had deliberately chosen adequate solutions that could be mass-produced rather than optimal solutions that required craftsmanship. December 21, 1943, Workshop 7, 15:45 hours, as afternoon advanced and the snow continued falling outside. Wagner expanded his analysis into uncomfortable territory. He retrieved a worn notebook from his briefcase, containing observations and calculations he had been compiling throughout the war regarding German industrial capacity and production challenges. The Wehrmacht, Wagner explained, operated hundreds of different vehicle types, trucks, cars, motorcycles, half-tracks, and various specialized equipment acquired through capture, requisition, or domestic production. This variety created catastrophic supply chain complexity. Each vehicle type required unique spare parts, specialized tools, and specific technical knowledge. Field maintenance units struggled to maintain adequate parts inventory, often cannibalizing damaged vehicles to keep others operational. Training mechanics required extensive time because knowledge of one vehicle type didn't necessarily transfer to another. By contrast, American forces appeared to be standardizing around a much smaller number of vehicle types, with radical parts interchangeability even between different manufacturers. The Jeep exemplified this approach. Willys Overland and Ford both manufactured virtually identical vehicles, interchangeable down to individual components. This standardization multiplied logistical efficiency in ways German planning had never achieved. Wagner walked to the chalkboard mounted on the workshop wall and began sketching calculations. If American industry could produce jeeps at the rates intelligence suggested, and if those vehicles required minimal specialized training or supply chain support, then America could potentially field mechanized units at scales Germany simply could not match. The numbers became increasingly grim as Wagner continued his analysis. German vehicle production faced constant constraint from limited resources, bombing damage to factories, and shortages of skilled labor. American production, apparently, faced none of these limitations and was actually accelerating. The Jeep represented more than just a vehicle design. It represented an industrial philosophy that could simply overwhelm German capacity through sheer volume. Zimmermann and his team listened in growing silence as Wagner's analysis continued. They had begun this project expecting a routine technical evaluation. Instead, they were confronting uncomfortable truths about industrial capacity, manufacturing philosophy, and the fundamental economic realities underlying the conflict. December 22, 1943, Workshop 7, 09:15 hours. The morning brought clearing skies and colder temperatures, the thermometer registering -12 degrees Celsius. Inside Workshop 7, Zimmermann proposed an experiment that would test whether German manufacturing could replicate American production approaches. They would attempt to manufacture a simplified component using American-style techniques, generous tolerances, minimal hand fitting, designed for rapid assembly rather than optimal performance. Kohler selected the Jeep's throttle linkage as a test subject, a simple mechanical assembly connecting the accelerator pedal to the carburetor, consisting of several stamped steel brackets, a connecting rod and pivot points. The American design used stamped parts with relatively loose tolerances, assembled with standard fasteners and simple bushings that allowed some slop in the mechanism but provided robust functionality. A German engineer would typically design this component with closer tolerances, precision machined parts and careful adjustment during assembly to eliminate any unnecessary movement. Kohler prepared technical drawings for the simplified American-style approach, and Braun gathered materials from the depot's machine shop. Over the next several hours, they attempted to manufacture the component using available equipment and materials. The experiment quickly revealed fundamental challenges. The depot's machine shop, like most German facilities, was equipped for precision work. Lathes and milling machines capable of holding tight tolerances, staffed by skilled machinists, trained to produce high-quality components. The tooling and procedures were optimized for quality rather than speed. Attempting to manufacture parts with deliberately looser tolerances felt counterintuitive to the machinists, who kept instinctively reverting to more precise approaches. When Weber explained they wanted parts that were good enough, rather than as good as possible, the machine shop supervisor looked genuinely confused. More significantly, the stamping operations, required for the American-style brackets, would need specialized dies and presses, equipment the depot didn't possess, and which would require significant setup time and capital investment to create. The American approach assumed access to high-volume stamping capacity, probably producing thousands of identical parts per day to justify the die costs. German manufacturing more typically used general-purpose equipment to produce smaller quantities of more varied parts. By late morning, they had produced a functional throttle linkage assembly, but it had required nearly 3 hours of skilled machinist time and had cost more in materials and labor than the original American part was probably worth. December 22, 1943, Workshop 7, 16 hours. The afternoon brought a visit from Oberstleutnant Heinrich Brandt, the depot commander, who had heard about the Jeep evaluation and wanted to understand what his technical teams were discovering. Brandt, a career logistics officer with extensive experience managing supply chains and vehicle maintenance operations, arrived with his adjutant and spent 30 minutes receiving a detailed briefing from Zimmermann and Wagner. The team showed him their documentation, explained their findings about standardization and manufacturing philosophy, and demonstrated the component replication experiment. Brandt listened attentively, asking pointed questions about production rates, supply chain implications, and maintenance requirements. His experience in military logistics made him immediately grasp the implications of American standardization approaches. After the briefing, Brandt requested a private discussion with Wagner in the depot's administrative office. Zimmermann and his team continued working, but an hour later, Wagner returned alone, his expression grave. Brandt had asked Wagner to prepare a formal report on their findings for submission to higher headquarters. More significantly, Brandt had shared information that put their technical discoveries into broader strategic context. Allied bombing campaigns were systematically destroying German industrial capacity. The raids on Hamburg, Cologne, and the Ruhr Valley had devastated production facilities. Skilled workers were increasingly being conscripted for combat duty, leaving factories understaffed. Raw material shortages were becoming critical as supply lines from occupied territories became less reliable. Meanwhile, intelligence reports suggested American industrial production was reaching extraordinary levels, not just in vehicles but across all categories of war material. The American economy had apparently fully mobilized, with massive factory complexes producing equipment at rates that seemed almost fantastic. German intelligence analysts struggled to believe the reported numbers, assuming they must be exaggerated or based on flawed methodology. But if even half the estimates were accurate, the industrial disparity was staggering. Wagner shared one final piece of information that hung heavy in the cold workshop air. Brandt had mentioned that experienced logistics officers privately discussed scenarios where German forces might eventually face equipment shortages, so severe that captured enemy material would need to be pressed into service in increasing quantities. The Jeep sitting in their workshop, initially just an unusual technical curiosity, suddenly represented something more ominous, a preview of a future where German industry simply could not keep pace with Allied production. 2 days before Christmas, the team reconvened in Workshop 7 for their final comprehensive analysis session. The weather had moderated slightly, with temperatures climbing to just below freezing and overcast skies threatening more snow. Throughout the depot, activity had slowed for the holiday season, with many personnel granted leave to visit families. Zimmermann's team, however, had voluntarily remained to complete their evaluation. Over the past 9 days, they had completely disassembled the Jeep, examined every component, documented countless details, and conducted extensive comparative analysis. Now they faced the task of synthesizing their findings into coherent conclusions. The workshop floor resembled an automotive anatomy lesson, components organized into functional systems, each tagged and documented. Weber had created a comprehensive parts catalog, listing every item with measurements, material specifications, and observations about manufacturing methods. Kohler had photographed the entire disassembly process, creating a visual record that accompanied their written documentation. Brown had compiled notes on field serviceability, identifying which components could be maintained or replaced by soldiers with minimal training and basic tools. Zimmermann organized their findings into categories for the formal report: design philosophy, manufacturing methods, standardization approaches, supply chain implications, maintenance requirements, and overall assessment of combat effectiveness. Each category revealed the same fundamental pattern. American engineers had consistently prioritized mass production capability and logistical simplicity over technical sophistication or performance optimization. The Jeep's engine, while less powerful and efficient than comparable German designs, could be manufactured in enormous quantities using less skilled labor. Its transmission, though simpler than German counterparts, provided adequate performance while enabling rapid assembly and easy field maintenance. Its body construction, less refined than German practice, nonetheless protected occupants while minimizing manufacturing complexity. Its electrical system, standardized throughout, simplified both production and logistics. Every major system reflected this consistent philosophy. Wagner arrived mid-morning with additional information he had gathered from contacts in Stuttgart's industrial sector. Several major German automotive manufacturers were struggling with production challenges that highlighted the contrast with American approaches. Daimler-Benz was behind schedule on truck production because bombing had damaged a critical supplier of specialized transmission components. Opel's Brandenburg plant had experienced severe quality control problems after losing skilled workers to military conscription. BMW's motorcycle production faced material shortages that were forcing design modifications and creating parts compatibility issues with existing inventory. These specific challenges illustrated a broader vulnerability. German manufacturing's dependence on specialized components, skilled labor, and complex supply chains created numerous points of failure.